it's all happening.
Life is happening.
All right, I'll monitor.
Do, 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 do. Welcome, welcome. We are here. It's Math Thursday. All right, guys, welcome to Math Thursday. So we're going to start off with a little bit of fraction fun. And when you get an answer, let me know what it is. Pop it in the chat. All right, we're starting to get some answers in the chat. So if you can work this out, excuse me. Pancake Mix, how you doing? Then we got 1 3/10 and 13/10. We have 3, we have 5/2. We have all sorts of questions or all sorts of answers, huh? This is a minus here. And this is a plus. I'm just kind of looking at my screen. It seems like it's a little maybe hard to see. Oh, over on YouTube, let's see, we got 5/2. I stumped Mickey already. Oh my goodness. So guys, welcome to those of you who are new to the channel or just joining us. I'm Sarah, I'm a math teacher, and I've been teaching science and math for a really long time. And so I'm here just to answer questions. If you have any content that you're kind of confused about, maybe you have a test tomorrow, maybe you have a midterm tomorrow, pop it in the chat and we'll see what we can do. Okay, so let's go ahead and let's get into this one. So the first thing we need to do, which a lot of you picked up on, which is excellent, is that we need a common denominator, because 2/3 and 4/5 and 1/6. These are all different sizes of pieces of the whole circle or the whole amount. Okay, so what we need to do is we need to make sure that these are all over the same denominator, because the reason we want them over the same denominator is because that means that we cut each of those like holes into the same number of slices, which means those slices are all the same size. Okay, so 3, 5, and 6. So the easiest way to figure out a common denominator is to just multiply them together. That's really easy when you have 2, but when you have 3 like this, I don't want to multiply all 3 of these together. So luckily, I look at 5 times 6, and that's going to be 30, and that is also divisible by 3. So I'm going to make everything over 30. So 2 over 3, so 3 times 10 is 30, so 2 times 10 is 20. And then my plus and my minus is going to stay the same. So then 4/5, 5 times 6 is 30, so 4 times 6 is 24. And then this one is 1/6. But to put it over 30, we do 6 times 5 is 30. 1 times 5 is 5. Okay. So now we go through and we've got 20 plus 24, that's 44. 44 minus 5 is 39. So once they're all over the same denominator, that's always going to stay the same, because now we're just figuring out, well, how many pieces do we have, right? So we had 20, we added 24, and then we took away 5. So we've got 44 minus 5, which is 39. Okay, so we have 39 over 30. Now, if we simplify that, which we can, because these are both divisible by 3, right? So 39 over 30, I can simplify that. And simplifying just means I'm going to reduce it, which means I don't want them to be like, if they're divisible by the same number, I go ahead and I divide them by that number. So I'm going to divide both top and bottom by 3, and I get 13 over 10. Okay, now when we've got like 13 over 10 in Algebra 2 and upper levels, usually leaving it as an improper fraction or a top-heavy fraction like this is okay. But if you're working with fractions a lot, you're probably going to put this into a mixed number, which is 1 3/10. Okay, because 10, like you have 13/10, so that means that you have 1 whole, so you have 10/10 and 3/10 left over, so you have 1 3 over 10. Okay. All right. Okay, let's see. So like I said, if you have any questions or comments or anything you want me to go over, put it into the chat and I will get to it as best I can. Okay, all right, so Hunter, CPCTC for geometry. Okay, and then Dylan, let's see, okay, so we'll do CPCTC. And then Dylan, you're doing, going from like slope-intercept form into standard form, right? Okay. Just writing these down. Okay. All right. Hi, Ava. All right, let's see. Okay, so CPCTC. CPCTC. Those of you who are in geometry right now, you know these initials if you are writing proofs. CPCTC. So you can use this in a couple different ways. So CPCTC, what it stands for is corresponding parts of congruent triangles are congruent. CPCTC, corresponding parts of congruent triangles are congruent. So if I have two congruent triangles, let's say this is DOG and this is CAT. Okay, and I tell you that triangle DOG is congruent to triangle CAT. Okay. So what that means is the triangle DOG is congruent to CAT, which means they have the same angle measures and the same side lengths. Okay. Excuse me. So that means that angle D is congruent to angle C. Because if we look at our congruent statement here, we've got D and C. Okay, so the same order it's going to match up because they're corresponding. Their corresponding parts in congruent triangles are congruent. So then O, angle O, is going to be congruent with angle A because they're in the same order. And then angle G and T, those are also going to be congruent. Ooh, Ronnie, I hope it went well teaching this lesson. Okay, so then that goes for the angles, which is pretty straightforward, but it also goes for the side lengths. So if I look at these orders here, I can write out some congruent statements for these side lengths, right? So, and I can just look at the order in my congruent statement. So side DG, so DG, that's the first and last letter of this triangle, is going to be the same. It's going to be congruent to the corresponding letters in the other triangle, which is C and T. So the side DG is congruent to the side CT. So corresponding parts in congruent triangles are congruent. Okay, so CPCTC. So you use this a lot in your in like proofs, proof writing, things like that. When you're trying to prove that these two triangles are congruent, something like that, that's where you would get into this CPCTC, okay? All right. Ooh, Evan, I hope you did well on your test. Okay, So another question that was asked, that was put on my list, is, I can't remember who it was that asked it, but we're gonna do, so going from slope-intercept form to writing in standard form. Okay, so slope-intercept form is, I didn't mean to do an equal sign, I meant to do a colon, is y equals mx plus b. Okay, where you've got the slope here and you've got the y-intercept here. Standard form is ax plus by equals c. Now the caveat to this is that A, B, and C, well, A and B, that you can't have fractions in here. Okay, so sometimes you have to do some little like tricky multiplication to make sure that there's no fractions, and also your A needs to be positive. Okay, so the example that somebody gave me earlier was writing y equals 7/8 x minus 3 and writing it in standard form. So this is slope-intercept form. My slope is 7/8 and my y-intercept is -3. So to get it into standard form, I first need to get x and y on the same side. But I also know I need to get rid of that fraction. anytime you need to get rid of a fraction or you want to get rid of a fraction, if you multiply by the denominator, multiply everything by the denominator, that fraction goes away. So in this case, I'm going to multiply everything, both sides, all the way through by 8. Okay, so when I do that, I get 8y equals 7x, because 7/8 times 8, the 8's cancel out and I'm left with just 7, minus 24. I'm going to subtract 7x, subtract 7x. So now I've got it as negative 7x plus 8y equals negative 24. So remember that a value can't be negative. So now I'm going to multiply everything by -1. So I'm basically going to flip all of the signs. So I get positive 7x minus 8y equals 24. And that would be my standard form. Okay. There are other ways that you could do that for sure, right? You could subtract 7/8 from both sides first and then multiply by -8. Either way, right? That's totally fine, however you want to do that. Okay, let's see. All right, Katie, let's see. Katie is asking for the end behaviors of a polynomial expression. Okay. And then, oh, I love standard form. There's something very sort of like elegant about it. I really enjoy standard form. Let's see. Oh, okay, so we can do a follow-up with OP, I don't know. Do a point slope form into slope intercept with 3/4 as the slope and the point is 2, 5. I feel like it's a very specific homework question, but that's fine. That's what I'm here for. Okay, so point slope form is y minus y1 equals m times x minus x1. So this x and this y are going to stay as x and y. Okay. And let's see, we're given a slope of, so m equals 3/4. And the point was 2, 5. Okay. All right, so I'm gonna just plug in what I know. So I've got y is gonna stay as y, and then I'm minusing my y1, which is 5. That's the point part of the point slope, right? And then my slope is 3/4 and x minus 2. So that is point slope form. If I want to go into slope intercept form, I want to get that I want to get that y by itself. Okay, so I'm going to distribute that 3/4. So we're going to go from point slope to slope intercept and then to standard form. Okay, that's what we're going to do. So we've got our point slope, check. So now I'm going to distribute the 3/4. So we have y minus 5 equals 3/4 x minus 6/4. I know I'm just going to leave it as 6/4 for now. So I multiplied that 3 there for the 2, right? So it's minus 6/4. And then I'm going to add 5 to both sides, and I'm going to have 3/4 x. Now, I'm going to do a little side note. Okay, so over here, I need to add, I have negative 6/4, and I need to add 5 to it. Okay, 6/4 can be simplified to negative 3/2. And then if I'm going to add 5 to this, remember we need to have it over 2. So that would be 10/2. Negative 3 plus 10 gives me 7 halves. So this is plus 7 halves. Okay. So my y-intercept is 7 over 2. So here, that is that's our slope-intercept form. So we had point-slope form, slope-intercept form. Now if we want to go to standard form, which if you recall, remember it's that ax plus by equals c, but I can't have any fractions in there, right? So to get rid of a fraction, we multiply by the denominator. So in this case, I have two different denominators. I have 2 and 4. Well, if I multiply by 4, I'm actually going to get rid of both of those because it's like 2 goes into 4. So now I'm going to multiply everything by 4. Okay. So now this becomes y equals 3x plus 14. And I need to get it over here. So I've got minus 3x plus y equals 14. All right, so now, oh, I don't need this other board. So now I've got the x and the y on the same side, but now I can't have that be negative. So I'm going to multiply everything by -1. So I have 3x minus y equals -14. And that's going to be my standard form. So that's my standard form. Here's my slope-intercept form. And here's my point-slope form. Ta-da! Okay. I did forget to multiply y by, oh my gosh, that should be 4y. Thank you, good catch. Plus 4, oh my goodness, and now minus 4. Good catch, I did forget to multiply the 4. Multiply everything, kids. Okay. All right. Look, it's been a long week for everyone. Okay, so I've seen a lot of questions about radicals. End behaviors. Yes, I can do end behaviors next. And radicals and polynomials kind of all go in with that. Oh, Aaliyah, y by 4? So I multiplied by 4 because I wanted to get rid of these fractions. So I multiplied by the 4 to get rid of this one, and the 4 also got rid of that one because it kind of simplifies. Okay. All right. So end behavior of polynomial expressions. Okay. So end behavior of polynomial expressions is actually pretty straightforward. Okay, if you can figure out what kind of degree it has. Okay, so with polynomial expressions, you really only have 4 options. Okay, so with a polynomial expression, if it is even, okay, now polynomial expressions are like, you've got a bunch of different exponents and things like that, and they get kind of like crazy curves. But the end behavior is, what does it do? Where are the ends going, right? Are they going in opposite directions or are they going in the same direction? So if you have even polynomials, okay, it's an even degreed polynomial, the end behavior is going to be where they're both going in the same direction. Okay, so both arms are going to go in the same direction. So maybe it looks like something like this. Okay, where they're both going up at the ends. Or it might be something like that, where they're both going down to the end. Okay. Now, this is if it's even and it's positive, they're both going to go up. Okay, even is going to be the same, odd is going to be different. Okay, so even and positive, they're both going up. Okay, even and negative, is where they're both going down. Now, if you need to, so if you have to write this out, right? As x goes to positive infinity, f of x is going to positive infinity. As x goes to negative infinity, f of x is still going to positive infinity. Okay, it's the same thing. The x values, they're gonna go to the same destination, right? They're either both gonna go to positive infinity or negative infinity. Because over here, they're both going down. So as x goes to infinity, f of x goes to negative infinity because they're both going down forever. And as x moves to negative infinity, f of x also goes to negative infinity. Okay, so they're both going down. Okay. So now odd degrees, so even degrees, they're both going the same direction. So odd degrees, they're going in opposite directions. Okay, so if they're odd, might have written these a little too big, but that's okay. All right, so odd, that means that they're gonna look something like this. Like it kind of goes like that. Okay, they're going in different directions. Okay, so we could even have like that, like that. Okay. So if you have it going like this, so what I like to do is if you kind of like use your pencil or your pen and you see like, okay, so if they're odd, they're going in different directions, right? It's like an odd number, right? They're going in different directions. I don't know why it's an odd number is going in different directions, but it just is. Okay, so they're odd, so they're going to be going in different directions. To figure out if it's positive or negative, I like to go back to like the basics of slope, right? So here, if I connect those two ends, the direction of my pencil, that is a positive slope. So that means that this is odd and positive. Okay, here, I would connect my two arrows. Doesn't matter what's going on in the middle, right? The end behavior is the end behavior. So here, it's a negative slope. That's a negative polynomial power, or negative polynomial. Okay? So here, when you're writing this out, as x is going to positive infinity, right? F of x is also going to positive infinity. As x is going to negative infinity, so as x is decreasing, f of x is also going to negative infinity. Okay. Yeah, this is algebra 2. This is algebra 2, high school, upper high school. Okay. So here, but you know what? This is one of those things though, that even though it is mainly in algebra 2, I think a lot of you, even a lot of middle schoolers, could probably pick up on what's going on with this, right? Okay, so then here, as x is going to infinity, right, f of x is decreasing. So f of x is going to negative infinity. I ran out of room there. Negative infinity. And as x is going to negative infinity, f of x is going to positive infinity. We're just talking about where it's going, like on a graph, right? Now, all this swoop-a-doop in the middle is all from all the noise that's inside the middle of the polynomial equation, right? Duck, I think that's a great idea. We need more math teachers, and especially people who have always wanted to be a math teacher. It's a really great job. I know a lot of teachers, I don't know, it's kind of become like a trend to just sort of like complain about being a teacher and stuff like that. I love it. Like, it's hard, but I really love being a teacher, and I think more people should speak up about how much they love teaching and enjoy teaching. Yeah. Okay. All right, let's see. Yeah, leading coefficients and degrees. Yep. So the degrees are even or odd, and the leading coefficient is positive or negative. Okay. So let's see. So something like, whoops, not that. Okay. So let's do like an example. An example equation would be if we had something like, if we did y equals, ooh, that's not a great marker. We did y equals x to the 4th plus 3x cubed minus 9x squared minus 4x plus 1. Okay, so the degree in this polynomial is 4. That's even. Okay, 4 is an even number. So we're looking at these two, right? So we know that the ends are going to be going in the same direction. Okay, and now the leading coefficient is the very, very first coefficient. So in this case, it's a positive 1. So we're looking at even, so same direction, and positive, which is up. Okay, so it's going to be just like this. It's going to be even and positive. Okay, if this were y equals negative 2x to the 4th, so it's still an even power, it's still an even degree, but now it's negative, right? Because we've got a negative 2 here. So now they're still pointing in the same direction, but down now. Okay, and all of this noise in the middle, that's what makes it like up and down or however it's going to move, okay? So then if this were a 5, okay, so if that were a 5, so now it's not an even power anymore, it's an odd power. So odd power means that they're going to be pointing in different directions, one up, one down. And the leading coefficient is negative. So here we go, right here. So it's odd and it's negative. So they're going to be pointing, ooh, I don't know if this is backwards on the lens or not. Ooh. But it's going to be pointing this direction, right? It's going to be going kind of down and to the left. So for me, it would be like this, but I don't know if that's backwards for you guys or not. It's like this. But this is my right hand going down and my left hand going up. So it would look like this. Yeah. Okay. Yeah, so the leading coefficient is always the one with the highest degree. That's the degree you look at, and that's the coefficient you look at. Yep. Okay. Yeah, whether it's in standard form or not, it's the highest the highest degree is where you figure out if it's even or odd, and the coefficient that's attached to that highest degree is the positive or negative. Okay. All right. Let's see. Okay. How would I write an answer if there is a limit on it and stops at a specific point? Katie, do you mean like with these? Or or am I coming into this late? Okay, so, oh yeah, so if it ends, right, it would be like as x approaches to, or what you would kind of have to think about the coordinate. Mickey, no, that's a really good question though. But the negative to the power of the coefficient doesn't affect the degree of the polynomial itself. So the degree is just based on the exponents that are attached to the variables. But that's a good question to think about. Yeah. Okay. Okay. So that's exciting that's what you're learning about right now. Okay, let me go back through. Let me see. I'm sure I've missed some. I'm sure I've missed some questions and things like that. But yeah, if you need any help, oh, Vexen, do you think in the future with science, et cetera, could we live on another planet? I think yes. I definitely think yes, we could, for sure. Okay, over on YouTube, we've got, dividing polynomials. Yeah, we can definitely do dividing polynomials. Okay, so let's go ahead and, because, we're already talking about polynomials. Why not? All right, so dividing polynomials. So we're going to start with long division, and then we're going to go into synthetic division. So dividing polynomials is really nice because what you can do is it can be really useful for when you're finding roots and things like that. Okay, so when you're trying to find roots, when you're trying to solve polynomials, and you've got the root theorem and the remainder theorem and all that kind of stuff. So it can be really fun. Okay, so polynomial long division. So I just pulled up a question up here. So let's do 6x squared plus 7x minus 20. And we're going to divide it by 2x plus 5. Okay. It is fun. I like doing long division. I mean, I like playing around with polynomials. That's my favorite thing. It was not my favorite thing when I was in high school. Ooh, it was rough, but. Okay. Which I think is probably a reason why I'm pretty patient with this stuff and with teaching, is because I know it's really tough. Okay, let's see. All right, so long division is just like the long division that you probably learned in like 4th and 5th grade. Okay, so we have this divided by this. So 2x plus 5 goes outside the house. And then inside the house goes 6x squared plus 7x minus 20. Okay. So remember, just like when you first learned how to do long division, right? You do this times this equals this, subtract. This times this equals this, subtract, right? And bring down the next term, all that kind of stuff. It's the same exact process. Okay, now when we're doing this, we only are paying attention to this right here and this right here. The 2x, we're paying attention to the 2x and the next term that we're looking at. So we think, okay, 2x times what equals 6x squared? Well, it's got to be 3x. So 3x times 2x gives me 6x squared. This plus 5 is just along for the ride. Okay, now notice that I kind of moved this. I had the x, I put the 3x over the 7x, okay? You kind of keep them lined up, right? It's all about organization. So 3x times 2x gives me 6x squared. 3x times plus 5 is plus 15x. And then I subtract 6x squared minus 6x squared, those are gone. 7x minus 15x is negative 8x. And now I bring down the negative 20. Okay, and now I go again. And I just pay attention to my first two terms. So 2x times what is negative 8x? 2x times negative 4 gives me negative 8x. Negative 4 times 2x is negative 8x. Negative 4 times 5 is negative 20. Oh, look at that. Minus, that's 0, plus 0, that's no remainder. So our answer is 3x minus 4 with no remainder. Okay, beautiful, right? It's beautiful. So let's talk synthetic division. Okay. Okay, so synthetic division, and we'll do this with the same problem. Okay, so we've got 6x squared. Synthetic division is just a way of doing this process without really, well, I shouldn't say without really, but it's with mainly just looking at I don't want to do this with synthetic division. I don't want to do this with synthetic. Let's pick another one for synthetic division. Okay. So when you're looking at this, you're just looking at when you've got when you're just looking at the coefficients. Okay. Sorry, I completely lost my train of thought there, guys. Sorry. Okay. So if we have, let's see. So if we have 2x cubed, start with a little bit higher degree, minus 7x squared plus 4x. The reason I didn't really want to do that other one, say it's divided by x plus 2. Okay, it was because it had a coefficient in front of the x, and that was just kind of annoying. Okay. All right, so synthetic division is just looking at the coefficients. So I'm going to set this up with this little like kind of grid thing, and I'm just going to copy down just my coefficients. And that's 2, -7, and 4. Now there's one that's invisible over here. You want to have all the degrees accounted for, including x to the 0, which is just 0, right? Well, 0x to the 0 power would just be 0. So I'm going to put this 0 down here. Okay. All right. Now out here, I'm going to do the root of this. So x plus 2, what I'm going to put out here is a -2. Okay. So the first thing I do is I bring this one down, and that's a 2. Okay. I do -2 times 2, which is -4. And then I add. I have -11. Okay. So -11 times -2 gives me +22. Okay. And then I add them together, and I get 26. -2 times 26 is -52, which is going to give me -52. Now that is my remainder. Okay. So -52 is my remainder. And remember, remainder is going way back, again, going way back to like elementary school, right? Way back to elementary school, that remainder is like a fraction of what you had originally, right? Oh, Ezekiel, you're hilarious. Bye. Okay. Okay. So what I do is these are now my coefficients for my answer. So this one was a 3rd degree. So my answer is going to be, 2, because of this 2x squared minus 11x plus 26, and then my remainder is minus 52 over x plus 2. That's my remainder. So my remainder goes over whatever I divided by in the beginning. Okay. So this is usually like algebra 2 that you would see. Yeah, you would primarily see this in like an algebra 2 class, certainly pre-calc and things like that. Yeah. Okay. All right, so we got dividing polynomials. Let me go back up into the chat and see. So C CZR, derivatives. We don't really get into derivatives on this channel, but if you have a specific question, you can pop it in the chat. And we've got a really good community here, so you can certainly ask your question, and then somebody might be able to help you out on that. Okay. But getting into calc stuff is a little bit tough. Oh, Luke, congratulations. 83 on your math exam. That's awesome. Oh, you live here in Michigan too. Oh, I know. Have a good winter break. I don't know if we're going to get a snow day tomorrow or not, but I think all of my students think we are, but I'm really pessimistic too. Okay, so solving systems of equations with 3 variables. Okay. Oh, nice, Matt. Okay, let's see. So solving systems of equations with 3 variables. Let me grab a practice problem. Okay. Let's grab one. Okay. Okay. Let's do this one. All right, so systems of equations, solving a system of equations, there's a couple different ways to do this, right? So systems of equations, you can solve by graphing, not very reliable, solve by substitution or elimination. Those are the 2 that you primarily will use. So substitution means that you solve one of the equations for one of the variables and plug it in and then solve for the other one. Elimination is where you can combine the equations together, and you can then like get a value for one of you combine them in a way that gets rid of one of the variables, so then you can solve for one of the other variable and then plug it back in. Okay, so let's do, Maddie, can you give me a little more information about what you need help with real numbers in Algebra 2? And then hopefully I can help you out. Okay, so we've got x plus y plus z equals 2. We have 6x minus 4y plus 5z equals 31. And we have 5x plus 2y plus 2z equals 13. Okay, so here is our system. Okay, so everybody got that down? All right. I need some more markers. All right. So what I'm going to do with these is when we have 2 variables, it's pretty simple, and that's what you usually work with. But with 3 variables, it gets a little bit complicated because you feel like, well, I can't just solve for one of the variables, right? It gets a little bit tricky. So what you do is you pick 2 of these 3 equations and you solve them. You basically kind of like work your way into what's a recognizable system of equations, and then you substitute it in, okay? So when we're looking at this, okay, I can just do, I mean, it doesn't really matter which ones you do, but I'm going to look at these two. And what I'm going to do is I'm going to get rid of, I'm going to use these two first, and then I'm going to use these two. And I'm going to get rid of the y. And the reason why is that I've got y here, I've got negative 4y, and I've got plus 2y. So I look at that. Those coefficients are really nice because first of all, I've got a negative there. If I multiply this one by 2, I can combine those to get rid of the y's. Okay, so I'm going to start with this one. So I've got x plus y plus z equals 2, and 6x minus 4y plus 5z equals 31. I'm not going to do anything to this one, but what I'm going to do to this one is I'm going to multiply this whole thing by 4. Okay, I'm going to multiply this whole thing by 4. I'm going to bring it down here, and I get 4x plus 4y plus 4z equals 8. And I'm going to add these together to solve by elimination. Okay. So when I solve these by elimination, 6x plus 4x, that gives me 10x. Negative 4y plus 4y, that actually cancels out, so I don't have any y's anymore. 5z plus 4z, that gives me plus 9z equals 39. So now I have an equation that I know it's true, but it only has two variables now, x and z. So now what I want to do is for this other set of two equations, I'm going to go with, oh, Pusheen, hold on just a second. I'm going to go with, I want to solve these two for x and z because then it's going to be a recognizable system that I can solve. Okay, Pusheen, how do you know when a number is a negative or it's just being subtracted? It's the same thing. Adding a negative is subtraction. Subtraction is adding a negative. So like 5 minus 2 is the same thing as 5 plus negative 2. It's all the same thing. Okay, so now I'm going to actually change my color so you guys can follow along a little bit. So we're going to do this one in orange. This orange marker is very juicy. I love it. Okay, I'm going to do this. Can I fit that all on here? Oh, it's going to get a little bit cramped, but that's okay. All right, so now I've got 6x minus 4y plus 5z equals 31, and 5x plus 2y plus 2z equals 13. Okay, I'm going to multiply everything here by 2. The reason for that is because I want to get rid of that y, so then I've got x and z like this one. So this becomes 10x plus 4y plus 4z equals 26. Okay. All right. So when I add these together, so now that I'm going to kind of cross that one out. So I ignored that one a little bit. So 6x plus 10x, that's going to give me 16x. The y's cancel out. 5z plus 4z, that's plus 9z. And 31 plus 26 is 57. So now I have a recognizable two variable system. Okay, so I've got that two variable system now. Now look at this, I've got 9z and 9z. That's easy. I'm going to do 10x plus 9z equals 39, and 16x plus 9z, which is 57. I'm subtracting now because of the 9z and 9z. So this is negative 6x. The z's cancel out. And then 39 minus 57 is negative 18. I'm going to double check because my brain is fried. Those of you who are teachers can understand it is negative 18. All right, so then x is positive 3. So there's my value for x. I've done it. I got that value for x. Now what I can do is I can go all the way back to my beginning system, and I can substitute in 3 for my x's. So I can do 3 plus y plus z equals 2. I can do 18 minus 4y plus 5z equals 31. I can do 15 plus 2y plus 2z equals 13. Then I can go through and I can get my solution. Okay, so three variable systems are, I think they're kind of fun because it is like solving a puzzle, right? And then you do this and do this and da 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 and all of that. Okay. Wait, why are you going to x by 4? Oh, multiply by 4. Oh, here. Sorry, this is from YouTube. So I multiplied by 4 because I wanted to get rid of that y. I wanted that negative 4y and that plus 4y. Okay. Okay. All right. Yes. So then you can also plug in, you can do 3. Oh, too far down. Right. Then I can take that and plug this 3 back in up here. And I can, sorry, right here. And I can figure out that z is 1. And then I can go back up and plug it in and it'll give me y. Okay. Now you want to make sure once you get your 3 values, you want to make sure that you plug it in and just double check. And that's just a calculator skill, right? Just kind of boop, 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 type it all in and then see, make sure you get 2, 31, and 13. Okay. All right, so I can do a little bit with radicals, and then it's probably going to be about that time to go ahead and call it a night. Okay. So with radicals, especially because I'm also out of boards. Oh, there's a nice one. Oh, it's very red. Yeesh. Okay. All right. So radicals, so simplifying radicals. If you guys have specific questions for radicals, put them in the chat so that I can, I know where to go with this. But if we have something like 24, okay, square root of 24 is not a perfect square, right? Or 24 is not a perfect square, but it has some hidden perfect squares in there, right? 24 is 4 times 6. 6 is not a perfect square, but 4 is. I can take the square root of 4, which is 2. I can't take the square root of 6, so that's going to stay as square root of 6. Just like that. Okay. So that's going to be simplified right there as 2 root 6. Okay. Oops. Okay, so if you were to have, so radical equations, I know is what you guys were kind of asking for. Okay, so if I have something like 4 plus the square root, I mean, even if we had like the square root of x equals 10, right? So my goal is still the same, is to get x by itself on one side. I'm going to subtract 4. So now I've got that the square root of x equals 6. So how do I get rid of a square root? I'm going to square everything, right? I'm going to square both sides. Square root of x squared is just x. 6 squared is 36. So x equals 36. Okay. Okay, so Maddie, you've got, so square root of x minus 7 is minus 7 under the root also, equals 7 minus square root of x. Is that right, Maddie? Did I write that correctly? Great. Okay. Okay, so we've got square root of x minus 7 equals 7 minus the square root of x. Okay, so let's work through this. A little bit of a better board. Ow! Oh, my ribs. Oh. Anybody watch any good TV shows? Okay. If there's any TV shows that I need to watch, let me know. Okay. So we've got x minus 7 equals 7 minus root x. Okay. Let's see where this goes. Let's square both sides. So root of x minus 7 squared is just going to give me x minus 7. And then if I square this, so 7 minus root x times 7 minus root x. So that's going to give me 49 minus 14 root x, and then plus x, right? So I'm just kind of foiling these together. I know I hate using the word foiling, but okay. So question marks, we don't really do derivatives on here, but yeah. Okay, so now I've got that. So I'm going to subtract x, those go away, right? So now I've got negative 7 equals 49 minus 14 root x. Subtract 49, subtract 49. So it's going to be negative 56 equals negative 14 root x. Divide by negative 14. Divide by negative 14. That is 4. So 4 equals root x. I'm going to square both sides. And I get that 16 equals x. There you go. Okay, so hopefully that was helpful with the solving radical equations and all that good stuff. Good, Maddie. You just kind of like, you know all the basics. So just kind of start trying stuff. You know, to get rid of a root, you square it, right? So try to just kind of work through it. But ultimately, a lot of it is just, you're just kind of solving a basic equation, right? Okay. Nicholas, I can answer a quick bio question. Lindsay, for geometry proofs, you know, come up with a logical plan first, then start figuring out which like theorems and all of that you need to actually use to write it out. And it's just going to be kind of practicing. That's it. Richard, exponential and logarithmic functions, they're really straightforward. Once you, and they're very closely related. So once you kind of figure out the basics about exponential and logarithmic functions, you're going to be all set. All right, guys, it is over an hour. So thank you for joining us and have a good night.
Did you call it OBS yet?
No, not yet.